afternoon, everyone. Today I'll be presenting my assigned part in this chapter 11.3. So I'll be presenting to you the example for the conclusion, and I'll be also presenting examples relating to my part. So we have example for a convergence series. So the series of the summation from n is equal to 1 to infinity, we have 1 over n squared plus 1. So we're just going to determine if this series converges or diverges. So we turn this series into a function. We have f of x is equal to 1 over, change the n here with x, we have x squared plus 1. So in order to perform the integral test, we're going to perform if this function meets the three requirements we have: if it is positive, continuous, or decreasing, for x is greater than or equal to 1. So our function here is positive simply because if we're going to plug in values of our denominator here, we say 1 squared plus 1, that is 2. We have 2 squared plus 1, that is 5. For 3, we have 3 squared plus 1, that is 10. So our value of denominator is always result to positive values, and that meets the first requirement. So next, if the function is continuous, as what we have observed, if we are going to plug in values here, we say values 1, 2, 3 to 5 and so on, we do not get the result of 1 over 0, since that would result as undefined. So we have for 1 we have 1 half, for 2 we have 1 fifth, for 3 we have 1/10, for 4 we have 1 over 17, and so on, and that is continuous. And lastly, it is decreasing, since if we are going to plug in values again here, as x increases, the value of our denominator also increases. But as what you have observed, our numerator 1 here remains the same, and that makes our fraction become smaller, since if makadako ang value sa tuwang denominator is magkagamay ang value sa fraction. So, and that concludes our function as decreasing for x is greater than or equal to 1. So we perform the improper integral here. For our function, we have the integral 1 to infinity of 1 over x squared plus 1 dx, that is equal to the limit of, as b approaches to infinity, we have the theorem of 1 over x squared plus 1. As you remember the other indefinite integrals before, the theorem, we have arc tangent x for 1 over x squared plus 1 approaches to 1 to b. So we have limit approaches b to infinity. We're just going to substitute b and 1 and do the subtraction. We have arctan b minus arctan 1, and arctan b is pi over 2, and arctan 1 is pi over 4. So pi over 2 minus pi over 4, that is equal to pi over 4. So again, we emphasize that pi over 4 is not the sum of the series. The series converges, but we do not know the value of its sum. So here, it doesn't mean nga ang kaning resulting value nga pi over 4 is mao na jud siya ang resulting sum sa atuang series. But instead, ang kaning integral test is gihimo ra nato ni siya kay para ma-determine if atuang series or atuang integral is converge ba siya or diverge. But it doesn't mean nga pi over 4 is mao na gini siya ang result sa series nato. Gets? So next, we have example exercises. So determine whether the summation of n is equal to 1 to infinity 1 over n squared plus 4 converges or diverges. So we let f of x is equal to 1 over x squared plus 4. So we turn this series into a function. So for x is greater than or equal to 1, our function here is positive, continuous, and decreasing. Since if we are going to plug in values here in x of our denominator, we always get the positive values. It's continuous, we say 1 squared plus 4, that is 1 over 5. For 2 we have 1 over 8. For 3 we have 1 over 13. And we can't get 1 over 0 here, so walay gaps, or yes, walay gaps sa tuang function. So that is continuous. And lastly, it is decreasing, since magkadako ang value sa tuang denominator, and again nagstay ang tuang numerator nga 1, and that makes our whole fraction and whole function as decreasing. So thus the integral test applies. So we do perform again its improper integral. So we have integral 1 to infinity of 1 over x squared plus 4 dx, that is equal to limit as b approaches to infinity. We have integral 1 to b, we have 1 over x squared plus 4 dx, and limit as b approaches to infinity. As you remember, we have theorem before, nakadiscuss data theorem before. We have 1 over u squared plus a squared, and the value of a here is 2, since if we are going to multiply 2 by itself, we have 4. So limit as b approaches to infinity, we have 1 over a, the value of a here is 2, and arctangent u over a, so our u is x, our a is 2, so 1 to b. Pagawas na to si 1/2, and then our arctangent b, that is pi over 2 minus arctan 1/2. Ato ra nang gi substitute si 1 sa tuang x, so we have this. So since the result is finite, the integral converges, so therefore the series converges. Another exercise, we have determine whether the summation of n is equal to 1 to infinity of 1 over the square root of n, is it converges or diverges. So we let f of x is equal to 1 over the square root of x. So again, we turn this series into a function. For x is greater than or equal to 1, our function is positive, continuous, and decreasing. Since if we are going to put value sa tuang denominator, if we have 1, we have 1. For 2, we have 0.7. For 3, we have 0.5. So as what you have observed, we always get the positive number or the positive value, and it also continuous, and lastly, it is decreasing as you observe. So thus the integral test applies. So we do the improper integral for this function. We have the integral 1 to infinity 1 over the square root of x dx. It is equal to limit as b approaches to infinity, integral 1 to b 1 over the square root of x dx. So limit of b approaches to infinity, we have 1 to b. As i-transform na to si ato ang fraction, we have x raised to the power of negative 1/2 dx. So limit as b approaches to infinity, as you remember the power rule, we have the negative 1/2 plus 1, that is 1/2, and our denominator here is also 1/2. So if we are going to divide 1/2 divided by 1/2, that is 2. So we have 2x raised to the power of negative 1/2, and we're just going to transform x negative 1 raised to the power of negative 1/2 to the square root of x. So we have 2 square root of x. So kuha na siya, gikan na siya sa power rule, and 1 to b. So limit as b approaches to infinity, we're just going to substitute and do the subtraction. We have 2 the square root of b minus 2 and the square root of 1, and limit as b approaches to infinity, we have 2b minus 2, and that results to infinity. So the series is equal to infinity, and that diverges. So as what you have observed, if ang result sa atuang integral is fixed number and infinite, nang nasa value ba, so tawag na to siya, ang function is nag-converge. And if wa siya fixed nga value or result, like this, is the function or the integral diverges. So, in conclusion, the section 11.3 introduces the integral test, which is used to determine whether an infinite series converges or diverges. So, in performing the integral test, function must be positive, continuous, and decreasing. So, the series is then compared with its corresponding improper integral. If the improper integral has a finite value, the series converges. And if it approaches to infinity, it diverges. So it simply means that the integral converges, the series also converges. And the integral diverges, the series also diverges. But it doesn't mean ang resulting sa tuang integral, sa improper integral, is mo ito ang sum sa tuang series. Yes, like that. Thank you for listening. That's all.